To simplify this expression so that it doesn't have negative exponents, let's break it apart. This is equivalent to x to the negative third times 1 over y to the negative 2 power. The first term, because it's a negative exponent, we can use the negative exponential property, which states a to the negative n is equivalent to 1 over a to the n power, to replace it. So x to the negative third power is equivalent to 1 over x to the third power. And we can likewise take this expression and move in this direction with our negative exponent to replace this fraction that has the negative exponent in the denominator with an equivalent of y to the opposite of that exponent. So the opposite of negative 2 is going to result in y to the negative 1 times negative 2, or second power. So we now have 1 over x to the third times y to the positive 2 power. Multiplying these together, numerators, we end up with y to the second, and in the denominator, we end up with x to the third. If you look at where we started and where we ended up with an equivalent expression, you can see that we have factors that move to the other side of the fraction bar had a change in the sign on the exponent. That leads us to factors and negative exponents. For any non-zero real numbers a and b, and any integers m and n, if we have a to the negative n over b to the negative m, it's equivalent to b to the positive m power over a to the positive n power. This illustrates that a factor can be moved to the other side of the fraction bar if the sign of the exponent is changed. And we have that here. Let's take a look then to simplify this expression. We can move the factors of x to the negative fifth to the denominator. Likewise, we can move this factor, y to the negative second power, to the numerator. The 16 is going to stay place. The negative 4 stays in place. The z will stay in place. What's moving is to have a positive exponent. We will switch its position from the numerator to the denominator and have x to the fifth. And likewise, to make a positive exponent, this is going to go up and switch it to a positive power. Simplifying this, the only thing, since the variables don't have anything in common, we will simply reduce our integer division here, 16 divided by 4, leaving us with 4 in the numerator. Positive divided by negative doesn't change the sign. Negative exponents do not affect the sign on our values. So here's a simplified equivalent expression for the given one. In this example, we have negative exponents again, and we can move this factor to the denominator, leaving the 20, so that it becomes a m to the positive first power. In the denominator, it is only the n that's to the negative 2 power, so 5 stays in place, but the n to the negative 2, to make it positive, will switch to the other side of the fraction bar to change the sign of the exponent. Simplifying this, 20 and 5 have a common factor of 5. 5 divided by 5 is 1. 20 divided by 5 is 4, leaving a 4n to the power 2 in the numerator, and a 1 times m to the first, or simply an m in the denominator, for our simplified equivalent value.